Hello student. So let us continue with the exercise of structure of atom. So the question says that you have to calculate the energy that is required for the process of removal of a electron from helium plus atom. So here is the equation related to it. So here we have He plus atom, and now one electron is removed from this atom, or you can say ion, to give He2 plus. Now in this thing, one information is mentioned that the ionization energy of hydrogen atom is considered to be this, that is 2.18 into 10 to the power minus 18. So this is the energy required to remove an electron from hydrogen. Okay, so this energy is used in this equation. Clear? Now if this energy is given, then this is applicable to hydrogen like species, because this is a hydrogen like species, it has one electron only. So this energy can be same for the helium plus atom also. So let us solve it. Okay, so if you remember the formula, so what is the formula for calculating the energy? So it is given as En, where n is the principal quantum number, minus 2.18 into 10 to the power minus 18. So we are calculating in terms of joule, so we'll take this only, then multiplied by z square by n square. So this is the formula. Now what we have to do is we have to calculate it for helium plus. Okay, so for helium plus, what is the value of n? Say, what is the value of n? Where is that electron located? That one electron, it will be located in the first orbit. And the value of z will be, z is here the atomic number. So the atomic number of helium is 2, that is 2 square, that would give us 4. So I'm just calculating n square, that would give us 1. So we have the value of n square, we have the value of z square. So what we have to do, we have to plug an electron from helium plus atom. So there is an energy related with this electron. If we apply that same amount of energy, then we can remove this. Okay, so how we will write it? So the energy change accomplishing this, so you can think it in another way also. You have to take the electron from n is equals to 1 to n is equals to infinity, because we are removing it out of the atom, so we can consider it for infinity. So what would be the energy for infinity? N is equals to infinity would give us 0. Why? Because we will put here minus 2.18 into 10 to the power minus 18, whatever be the z square. N square means infinity square, that would give us again infinity, and 1 by infinity value is 0. Got it? Therefore we have to move the electron from En to E infinity. So this is the final state, so we'll subtract it. So this value is equals to 0. So 0 minus then this value, that is for En. Here En is what? E1. Okay, so that would give us 2.18 into 10 to the power minus 18. Z square, the value of Z is 2. 2 square, that is 4 by 1. So that would give us 2.18 into 10 to the power minus 18 into 4. Clear? So if you calculate it, this will give us the value of 4 8 is 32, 3 carry, 4 1 is 4 3 7, and 4 2 is 8 with a positive sign into 10 to the power minus 18 joule. So let us see the solution. So E infinity minus this one, that would give us 8.72 minus into 10 to the power minus 18 joule. Correct? No problem. Here again we have done the same thing. E infinity value comes 0. E1, it is 2.18 into 10 to the power minus 18, 2 square by 1 square. Next, if the diameter of a carbon atom is 0.15 nanometer, what is given? The diameter value is given. So suppose this is our carbon atom and its diameter is mentioned as 0.15 nanometer. Now what we have to calculate? We have to calculate the number of carbon atoms which can be placed side by side. Side by side means like this. So we are placing each of the atoms side by side. Then it is asked that Suppose n n atoms can be arranged. So it is asked that how many atoms, what is the value of n here, that can be arranged so that it can cross the length of 20 centimeter. So how you would calculate it? So if one is taking 0.5, okay, so let us say that n numbers of 0.515 nanometer diameter spheres can be adjusted here. So the total length that will be covered will be equals to, so one is taking a length of 0.15, so n will take off 0.15 into n, and this length should be equals to how much? That should be equals to 20 centimeter. Clear? That is 20 centimeter and this is nanometer. First we have to convert this value into centimeter. How will convert it? So how I will convert it? So we know that 1 nanometer is equals to 10 to the power minus 7 centimeter. Okay. So for 0.15 it would be 0.15 into 10 to the power minus 7 centimeter into 20 centimeter. This 20, this will be cancelled out and n will be equals to 20 by 0.15 into 10 to the power minus 7. Okay, no problem. Now next you will calculate this value. So that would give us, this will give 2 zeros here, that is 200 into 10 to the power 7, okay, by 15, right, by 15. So you will calculate it further to get the value of n. So let us calculate it. 5 3 are 15 and 5 4 are 20, that is 0 again. Now 3 1 are 3 and 3 1 are 3, that would give us 1. 3 3 are 9, 33.33 into 10 to the power 7. So if you move it 2 decimal here, so we will increase the value of 8 by 2, 9. So that would be the number of atoms. Got it? So let us see the solution. So first we have here, it has been converted into meter square. Okay, no problem. We can do it in either way. So finally you will get the value of n as 1.3 into 10 to the power 9. So in this case they have first converted our centimeter into meter and also our nanometer into meter, and then they have just divided this thing to get the final value. Final value will be same because the number of atoms has no unit to be considered. Okay, now next, 2 into 10 to the power 8 atoms of carbon are arranged side by side. So in this case the n is given 2 into 10 to the power 8 atoms. They are arranged side by side. And what if the length of calculate the radius, we have to calculate the radius of carbon atom if the length of this arrangement is 2.14. So in this case we have the value of n. So suppose we consider that the value of radius of each carbon atom is, I am considering the radius as x centimeter. Okay, so the length that would be covered by this much number of atoms, that would be 2 into 10 to the power 8 into x, and this length is given equals to 2.4. Therefore we will get a 10 to the power 8 or 0. Sorry, 1.2 into 10, 1.2, finally 1.2 into 10 to the power minus 8. Okay, if you this is in terms of centimeter, you can write it in terms of angstrom also. So we can write the radius of carbon atom as 1.2 into 10 into 1.2 angstrom. Okay, so here they have written in terms of meter, no problem. You can write it in terms of centimeter also or meter also. That is totally, that totally, that totally depends upon you. So they have done the same thing, 10 to the power minus 10 meter. Clear? Now next, the diameter of zinc atom is 2.6 angstrom. Calculate the radius of zinc atom. So what is the relation between radius and diameter? Very simple. Radius is equals to diameter by 2. That would give us 2.6 by 2 angstrom or 1.3 angstrom. We have to calculate the number of atoms present in 1.6 centimeter if zinc atom are again the same question. So how many what is the radius of one carbon atom? So we'll take the diameter rather than radius. Okay. Suppose n atoms are there that can be arranged side by side to give this much length. So n into 2.6 will be equals to 1.6. So let us convert the centimeter into angstrom. So that would give us 10 to the power minus 8 angstrom. Okay. Further, we will just bring it here and that would give us 10 to the power minus 8. Okay. So we have to convert centimeter into angstrom. So we will multiply it by plus 8, not minus 8. So this will be gone. Now 16 by 26 into 10 to the power 8. So 2 8 is 16, 2 13 ja. If you try to calculate it, you will get it as so 13 6 ja, 6 ja 18, 6 1 ja 6, 1 7, 13 6 ja 78. 0.6 into 10 to the power 8 or 6 point how much? So that would give us 2, 13 1 ja 13 again. 6.1 into 10 to the power 7. Okay. So they have done the same thing. First we have calculated our radius by dividing it by 2. So they have calculated in picometer, no problem. Just if you know this conversion that 1 meter is equal to 10 to the power minus 12 picometer, then you can solve it easily. Now again they have divided 1.6 by 2.6, that is 6.153 into 10 to the power 7. So this will not be meter. This would be this much atoms. A certain particle carries a charge of 2.5 into 10 to the power minus 16. Okay, so we have to calculate the electrons present in it. Now, one electron carries a charge of 1.6 into 10 to the power minus 19. Now, suppose n electrons are there. N electrons are there. Therefore, charge on n electrons will be n into 1.6 into 10 to the power minus 18. And what is the total charge? Suppose this n multiplied by this gives us this much charge. That is 2.5 into 10 to the power minus 16. The number of electrons will be 2.5 into 10 to the power minus 16 by 1.6 into 10 to the power minus 19. Then how much it would be? This 19 will go upside and will give us 25 by 16 multiplied by 10 to the power 3. So 16 1 just 16. 16 and how much? 16 and 6? 22 and 3 9. 16 and 9. That is 9. Now 16. 6 is 36. 6 1 just 6 3 9. It is 90. So 16 5 ja 5 6 ja 30. 5 1 ja 5 3 8 80. Okay, so 16 5 ja. And again 10 carry. That is 0. Is 10 to the power 3. So this much number of electrons will carry this much charge. Okay, same thing is written here. 1.560 into 10 to the power 3. Okay, clear? So they have divided this charge by charge on one electron. That would give us number of electrons. Next, in a Milken's experiment, the static electric charge on the oil drop has been obtained by shining X-ray. If the static charge on oil drop is itna, calculate the number of electrons. Again, you have to calculate the number of electrons and the charge is given. So we know charge on one electron is 1.6 into 10 to the power minus 19. So let n be the value that will contain this much of charge. So it brings us to 1.282 into 10 to the power minus 18. So n is equals to 1.282 into 10 to the power minus 19, sorry, 18 by 1.6 into 10 to the power minus 19. Therefore, n is equals to 1.282 by 1.6 into 10, okay, or 12.82 by 1.6. This will give us 1282 by 160. Okay, clear? So if you calculate this value, you will get n is equals to 8. So they have divided first we have written the charge divided by the charge of one electron, that would give the number of electrons. Next, in Rutherford experiment, generally the thin foil of heavy atoms like gold, platinum, etc. have been used to bombard by the alpha particles. If thin foil of light atoms like aluminum, etc. is used, what difference would be observed? So what it is written? So they have taken heavy atom. Okay. So what is the meaning of this? Heavy atom and light atom. Heavy atom means the atom which have a smaller mass number, greater mass number. Okay. Now for light atoms, the mass number will be less. That is, the nucleus will also be small. Okay. Now if the nucleus is small, so if you remember the Rutherford experiment, then the alpha particles, if they are passed through this gold platinum, they were deflected back, and the reason for deflection was the presence of nucleus. Now in light atoms, what will happen? This nucleus density will be reduced to even a smaller area. Clear? It will be reduced to even a smaller area. So Rutherford used alpha particle scattering to reveal the structure of atom, and the nucleus of heavy atom is high and carry lots of positive charge. Lots of positive charge. So as a result, when alpha particle hit the nucleus, they are easily deflected back. A number of alpha particles were also deflected at tiny angles due to the nucleus substantial positive charge. Now, if the light atoms are used, then nucleus will be light and the nucleus will have a modest positive charge. As a result, the number of particles deflected back and those deflected at angle will be insignificant. Clear? So, if you consider larger atoms, they will have a greater size of nucleus and hence greater positive charge, and most of the alpha particles will be deflected because alpha particles are nothing but helium 2 plus, and helium 2 plus is positively charged. Okay, so due to electrostatic repulsion they were deflecting. But if you take light atoms, then light atoms nucleus will also acquire a small area, and hence it will require a small area. Therefore most of the alpha rays will pass through it without any difficulty. So what is the result? That the number of particles deflected back would be less, and we can say they will be insignificant, means of no importance. Next is symbol of this bromine can be written in this way, whereas symbol of this bromine cannot be written in this way. Why is this so? So it is written that this symbol and this symbol can be written, whereas this symbol and this symbol are not acceptable. What is the reason? So we know that the general convention that is followed for writing the symbol is this: the atomic number is on the top, then on the bottom we have the mass number, and here we have the element symbol. Before 79 is acceptable, but 35 BR is not. So for that reason we cannot accept this. So this is a kind of a reason of sign convention. Okay, so we generally represent it in this form, so it is true. We cannot write it in the other form. Okay, clear? And one more thing, I would add that atomic number are of greater importance rather than the mass number. Okay, so for that reason we cannot write it in this form. Clear? Next, an element with mass number. Okay, so one more reason here. So if you write 35 Br, suppose we are writing 35 Br, then it is not acceptable because mass number are not changing, but the atomic number will change due to existence of the isotope. Clear? Next is an element with mass number 81 contains 31.7% more neutrons. So it is written that 81 is the mass number, that is the number of proton plus number of neutron, and it is again written that 31.7% more neutrons are present as compared to protons. So if suppose the number of proton is x and the number of neutrons will be x plus 31.7% of x, means suppose we have 100 proton, then there will be 131.7 neutrons. So you can take this example, this illustration, that the number of neutron is is this plus 31.7% of this. Okay, clear? So we can put this values here, x plus 31.7 x by 100. Okay, so that would give us 81 into 100 multiplied by, so if you multiply 100 here also, that would give us 231.7x if you solve it. Now x will be equals to 8100 by 231.7. So this would give you the final answer. So here the same thing is written, that we have considered the number of proton as x and number of neutron as x plus 31.x. Now x plus 131.x is equals to 81. Clear? So that would give us the value of x if we just calculate it from here. So this is wrongly written. Okay, so we cannot write in this way, it is wrong. So we have to add this and this both, because mass number is equals to number of proton plus number of neutron. They have alone equated this number of neutron with the mass number. We cannot do it so. So we will take the number of proton, that is x. So it is written here, and the number of neutron is x plus 31.7x, and that is equals to 81. Okay, so if you calculate this value, then you will get the overall value. And 31.17 or 100%. Okay, this percent of x. Next, an ion with mass number 37 possesses a unit of negative charge. Okay, so it is written that ion, that is the number of proton plus number of neutron is given, and it is containing one extra electron, that is number of electron is equals to number of proton plus 1. This is given if the ion contain 11.1% more neutron than electrons. So what does it mean? So if you want to calculate the number of proton from here, so that would give us number of electron minus 1. Now next it is written that suppose we consider the number of proton as x, sorry, number of electron as x, then number of proton will be x plus 11.1 x. Number of neutron will be x plus 11.1 x. This is the number of neutron. This is the number of electron. Now we know that number of proton plus number of neutron is equal to 37. So we are just putting this value for number of proton, that is n of e minus 1. So that for x minus 1 plus number of neutron is x plus 11.1x, that is equals to 37. This would give us, this is of 100x. Okay, so x plus x 2x, 200x, or 211.1x. Here we will have minus 200 is equals to 3700. Further, you will calculate this 3700 plus 200, that is 3900, or x is equals to 3900 by 211.51. Clear? So here the same thing is written. They have first calculated the number of neutron in this way. Where they have and the number of electron present in a neutral atom is this. Now, therefore, the number of proton is also x minus 1. Now the mass number is 37. That is number of proton plus number of neutron. So x minus 1 plus this much. Okay. So that would give us 37 and 38 and 18 as the final answer if you calculate it. Last question. An ion with mass number 57 and 3 units of positive charge. So ion has a mass number of 56. That is number of proton plus number of neutron is given as 56. Okay, it is given as 56. Now, next it is containing 3 positive charge. So therefore 3 units of positive charge. What is the meaning of this? That it has 3 units of positive charge. Anybody? Try to do it just. Okay. Now the next thing that is mentioned is number of neutron is equals to 30.4 x plus x. Now we'll solve it. So if we consider that let the total number of electron be x, okay, so therefore the total number of neutron will be this much. Now since the ion is tri-positive, therefore number of electron in neutral atom is this much, and this will be the number of proton. Now the mass number is equal to number of proton plus number of neutron. That would give us x plus 3 plus 1.304x, 56. Finally we will get it as 23. So this is 56 is for iron, therefore we can write it as Fe3 plus with 56 as the mass number. We can further write it as in this way also, 56. And for iron, what is this? Say our atomic number 26, and here 3 plus. Got it? So this was for today's class. We have covered almost say 11 questions. We will cover the remaining questions in the next class. Thank you.